Hi, my name is Kyle Wonderland, and for my bio project, I was a part of the Red Tail Reach restoration that was led by LEAD. You can see over my right shoulder there's some of the other people that were a part of my work group on the very rainy day that I did my project. And our project was kind of off the trail, up the hill, spreading mulch and planting trees in a newly foresting area. You can see me here spreading mulch around some of the trees that are just lying dormant during the winter. And this mulch had a couple purposes. Most specifically, I was designed, or intended to rather, hold the ground in place to keep some of the soil from getting washed away in the heavy rains that the spring has. It also provides a slow release of that water into the ground for some of the saplings that were recently planted or had recently blown in from other places. Third thing was that it actually added nutrients to the ground that the soil had previously lacked in a natural way, so that we didn't actually have to use any chemical fertilizers. So the first aspect of what we talked about in class that I think applied to this project I want to talk about is the idea of transpiration. So like I said, the mulch was designed to release the water slowly into the ground, which was supposed to protect the small saplings who didn't have roots that reach particularly far out or particularly deep, and give them access to water. As we know, plants can't actually get the water they need through the leaves and things like that. You know, those are only designed to take in sunlight and to take in CO2 and release O2. All the nutrients and the water they actually need come from the ground and through the roots. We know that the process of transpiration happens through water's adhesive and cohesive properties that allow it to be drawn up through the plant, these little straws that go through the roots and up into the plant and up into the plant cells where the water is needed. And that's drawn through because of some idea of diffusion, where water is evaporated out of the stomata of the underside of leaves. Another important part of this mulch is that it replaced some of those nutrients that were lost in the ground, you know, the nitrogen, the phosphorus, the potassium, the things that are particularly important for plant growth. And in doing this, adding mulch as opposed to adding chemical fertilizers, we were protecting against the risk of having over-fertilization or have the fertilizers move into places that we didn't particularly want them, like with the case of eutrophication, like I'll be talking about in just a minute. Another important feature I want to talk about in regards to what was mentioned in class is the idea of niche partitioning. So niche partitioning is basically the idea that plants develop, you know, they evolve in different ways so they don't have to compete with each other if they are in the same space, which means they don't rely on the same resources, or they don't rely on those resources in the same time frame. Now, some people that were on my project were planting trees, and very specifically they were planting evergreen trees. There were already quite a few deciduous trees in that area, which is representative of a forest in its early secondary stages. You know, it's characterized by deciduous trees, by a lot of shrubbery, and by plants that have nitrogen fixing properties in their roots. However, by planting evergreen trees, they are opening up the possible niches, I guess you could say, available to plants in that area. Deciduous trees lie dormant during the winter. However, because of the way evergreen leaves are structured, they do not. They can continue to grow during the winter, which means there isn't necessarily that resource competition between those two plants. That means that there is an increased potential for biodiversity, not only in plant life, but also in animal life and in soil life, because those needles are going to get dropped all year round. Probably the most important of all of these things that I wanted to talk about is the idea of eutrophication. So like I said, the mulch is supposed to hold the dirt in the ground, and it's supposed to only allow, you know, small amounts of nutrients into the soil at a time, and it was not a chemical-based fertilizer, which means that there's not so much of a risk of over-fertilizing. What that would lead to is that would get quickly washed down into the river through the heavy rains that we undergo, and that would increase the carrying capacity of the algae that grows in the river. Now what would happen is an algae bloom, which means it would grow like crazy and create a film of algae over the top of the water. That would prevent sunlight from getting down into the water, and then eventually the plants at the bottom of the river or lake or whatever the case may be would die off. It would also, as the algae started burning through the nutrients newly available to them, they would start dying off as well. So that left a lot of dead plant matter floating around in the water. What happens then is these microbes come up from the soil from the bottom of the river and start processing that plant life. However, that actually requires a lot of oxygen, which they draw out of the water, and that eventually leads to these dead zones, these areas that are completely devoid of the oxygen needed to support animal life underwater. So this is particularly dangerous in this area, and particularly dangerous at this time because that river is a home for a salmon spawning area, which salmon obviously can't spawn if they're going to run the risk of being suffocated in the water. So having this mulch in the ground helps prevent that eutrophication process. This image is just to give you an idea of, what the water might look like if that silt got washed in, if that extra nutrients got washed in and led to these dead animals and dead algae floating around in the water. So clearly it's a really important project that needs probably more attention than it's currently getting. I really enjoy working with LEED, and I'm probably planning on doing it in the future. Thanks.